quadratics and linear later on in the year, so it's good to review systems of linear equations first. It's good for you guys to review graphing and all of that stuff since you've had a break. And we're starting second semester now. Let's start off in a good place. Let's actually focus and pay attention. If you have questions, please ask questions. Do you guys all understand that? We all got it? Okay. So, let's just talk about systems of equations. Let me just get all this up. Okay, a system of equations is two or more equations in the same variables. So what that just means is that you have two variables, x and y typically, but it doesn't have to be, and it has two equations or more. So that creates a system instead of it just being one single equation. The solution to a system of equations will be a solution that satisfies both equations. So what this means, is that the solution is true for both equations. So when you're solving by graphing, you're always going to graph the equations first. And yes, you have to graph them no matter what, whether you think you can tell me the answer or not before graphing. I don't care. You still have to graph it. And then the answer is the point of intersection. That point of intersection is your solution because it is a true order pair. It is an order pair on the line of both equations. That's what it means to satisfy both equations. That ordered pair is on both lines. So therefore, the intersection point is what makes that the solution. So your answer is always written as an ordered pair. Okay, when you're ready, you can flip to the next page. Okay, so the first thing we're going to do is graph both of these lines. So we have to get them into slope-intercept form. So how do I get 2x minus y equals 8 into slope-intercept form, Bree? Do you know what I mean by slope-intercept form?
That's y equals.
Yeah.
Subtract the 2x.
Perfectly fine, yeah. Then what, Bree? Y can't be negative, so how can we get rid of the negative? Not just one, but what? Two negatives make a... We want it to be positive, right? So we need two negatives. So we want that to be a... Yeah, do you see that? Because then that makes the y positive. So we have y equals 2x minus 8. Yes, Emmy. Yeah, instead of dividing by negative 1. Yeah, that's the same thing. Okay, so Nylan, I'm going to graph this. How do I graph y equals 2x minus 8? Where do you start if it's y equals 2x minus 8? Negative 8 on the x or the y-axis. So we go down to negative 8 on the y. Okay. So how do I use the slope then, Nylan?
You go up to
Good. Which way do I go over after I go up 2?
right.
Yeah, because we want it to be a positive slope. So we go up 2, right 1. And with systems, I always try to extend my points as far as I can because it makes it easier to find that point of intersection later on. Because sometimes your lines will go a little bit wonky as you're graphing them. And since we're going to be graphing more than one line on here, I'm going to call this one 2x minus y equals 8. Yeah.
Maybe if we like did this, put a 1 and a 2.
On the EOC, it will probably you could use function notation like f of x or g of x, and instead of using 1 or 2, you could call one f of x and one g of x. That's fine, but if it's not given to you, like I guess that's a way of doing it. I don't know if there's a way to do that on the EOC though. All right. How do I get x plus y equals 1 into slope-intercept form, Ryan? Perfect. So, Gabe, how do I graph that then?
You go upward.
I'm sorry. Yeah, I was distracted by Julian. You start at 1, and then what do you do?
You go down to the left one.
Down 1 into the left 1?
Well, you go
Which
up,
way?
Then you go, oh wait a second.
It's fine. I'm sorry, I just didn't hear you.
It's an access slope one. You go down 1 over the right one.
Yeah, we want that negative slope, so you want it to go left or right 1 after you go down. Julian, you can use the sharpener. I was super confused what you were doing over there, so you distracted me. You're fine. So your answer is the point of intersection. You can't just like circle it. You're not just done. You have to tell me that point. So what is my answer then? Jagger, what is my answer then?
3, -2.
3, -2. Let's see. Yep. So in middle school, I know they had you guys check a lot of your work, didn't they? At least that's what I've been told in the past. So I'm going to show you the check. It's not something you have to do, but it's just something so you realize why this is correct. So remember we said a solution is the point of intersection. It is the thing that satisfies both of the equations or makes both of the equations true. So if I substitute in the points 3, -2 for both of the equations, I do 2 times 3 minus a -2 equals 8. So that's 6 plus 2 equals 8. Is that true? Yep. Are you okay?
Yeah. That hurts me.
And then we have 3 plus a -2 equals 1. Is 3 plus -2 1?
Yes.
Yeah, so that one is also true. So since they're both true, you notice that that ordered pair satisfies both of the equations. So that's what that was meaning there. Again, you don't have to check every time, although it might be smart to check on a test or a quiz because that is worth a lot of points. Okay, questions on the first example? Gabe?
There's a crack in this one.
Yeah, there's cracks in a lot of them. I really have to buy new ones. I bought those at the end of the school year last year, and they haven't even lasted a year. It's really sad. And like I buy that kind of stuff with my own money, so it's really frustrating. It's not your fault. It still is a straight edge. It doesn't matter. You're not measuring anything. Cameron, how do I graph y equals 1/2 x plus 3? Up 1, right 2, up 1, right 2. Oh, I forgot to label the other line on this one, so I just went backwards. I'm struggling. So it's x plus y equals 1 on that one. So don't forget to label your lines. So this is y equals 1/2 x plus 3. Andrew Costelli, how do I get that point slope form equation in slope intercept form to graph it? Then what?
Add the one to the
Okay, so Andrew Placencia, can you graph that for me? What would you do?
Negative 1, right?
Mm-hmm.
And you just go the opposite way. No. Yeah. No, you go the same way. Up 2.
It's not up 2. Be careful. It's rise over run, and our slope is 1/2. So it's not up 2.
Up 1. Okay.
And then which direction over?
Right.
Yes. So it should be a positive slope, so it needs to go to the right. What do you notice about these two lines that you guys are graphing? They're parallel, and what do we know about parallel lines? They have the same slope, different y-intercepts. So that's one of the things we know. I heard somebody else say the other thing we know. So you'll notice here that these have the same slope, different y-intercepts. So you would have known that these were parallel just by looking at it, hopefully. Not all of you might have remembered that from last semester, but I'm hoping that a lot of you did. Somebody said never cross. Who was that? Nylan. That's really good and that's super important. Parallel lines will never intersect. So we said that our solution is the point of intersection, but Nyland informed us that parallel lines will never intersect. So what is our solution?
There's no solution.
There's no solution. They're never going to intersect. There's not a point of intersection. So your answer is no solution. Yeah, that's it. I want you guys to get started and asking me questions and whatnot.
When do you get out of here?
1:30. Don't forget it's Thursday, so you only have one more day of school tomorrow. I agree, Nick. I agree. What? Well, technically, with the calendars, like, the district makes, like, 3 different calendars and teachers vote on them. But, like, that doesn't mean there's huge changes. So it's usually nothing with the breaks and stuff. It's usually, like, where our work days and stuff land. So it's probably, like, the district level. Like, our breaks aren't really the things that we get to pick. You know what I mean? Like, it's more like, you need to have a teacher work day and this amount of PD days, and, you know, where do you want them? You know what I mean? Oh, no, but Kobe, do you want to put this into slope intercept form for me, please? Yep. Okay, tell me how to get it there. Then what? Okay, how am I going to graph that, Jerry? To the left 3? Will that be a negative or a positive slope if I were to connect those 2 points? Oh. If I connect those two, Jerry, would that be a negative or a positive slope? And we want it to be negative. So instead of going to the left 3, we should go to the... Yep. you go down to right 3. Did you hear me? Does that make sense, Nylan? All right. What do you guys notice about that other line? It's the same line. So we have to be careful here. So yes, it's the same line. So literally it would be one line on top of the other. But we have to talk about what that means in terms of the solution. It's not all real numbers, so that's why we have to be careful. And I'll explain why in a second. So we do know that it's typically all real numbers when stuff like this happens, right? If I would have given you like an equation like 2x plus 3 equals 2x plus 3, and you go to solve it, and you get 3 equals 3, you guys know that this is all real numbers, right? We've done this like all semester, for a whole semester. Now, what does all real numbers mean? Devin?
It means like all the numbers that are in there are integers.
They're more than just integers. You're right,
Oh, yeah,
the integers work. And decimals and fractions. And it's saying any of those integers, so negative and positive numbers that are whole, any of the decimals and fractions all work if you substitute it into this equation. That's what that's saying. Here's the problem. For a line, you need an ordered pair for it to be a solution. Because like a line on a coordinate plane, so it needs an ordered pair x and an ordered pair y. If we set all real numbers for this, we're implying any point works. But the problem with this is the point 1, negative 1, which is right here, is not a point on that line, is it? So we can't say all real numbers because that's not true. Not every single ordered pair works. Does that make sense? What this is implying is that every single integer, every single decimal, every single fraction works. So that is the issue with that there. So who knows what we should say instead? Who knows what we should say instead? Does anybody know? So this means infinitely many solutions. There's infinitely many ordered pairs along this line that work for solutions. So in this case, we write infinitely many solutions.